A warm welcome also from my side to this 24th Passive House conference. My name is Wolfgang Feist and I'm going to present here on the Passive House. This is not just a contribution to climate protection, but of course it is a contribution and a big one. As we see from one of the latest studies on the achievements of Passive House, it's about 90% reduction in the energy needs for a typical residential building. This is from the latest UK study, but if we look at the general results of a lot of passive houses which have been built in the past decades, we can see that from the contemporary average consumption, the reduction in heating energy is more than 90%. And that is, we have to keep in mind, heating is contributing 30% of the global energy consumption. So this is a huge reduction potential for the energy and at the same time for the carbon dioxide emitted by using these furnaces for heating. But the passive house does not only contribute to the reduction of the climate gases. It also makes it possible that at the end we can deliver all the energy from renewable energy. But this is especially a problem with the energy use during wintertime. You can see on this slide. You see there is the energy which is delivered by photovoltaic production in a typical cool, moderate climate. And you see there's a little bit of contribution during the winter, but not quite a lot. And even if you add the wind energy, this is the light blue one, you see, yes, now we can cover all these demands which are not heating, which are not concentrated in winter, but we have that big gaps during the winter in the time where we need heating energy. Now, this is for a passive house, and for a passive house, these demands for heating energy, they are quite low, so we can do that with a little bit of seasonal storage. But seasonal storage, of course, is something which is quite expensive, so we don't want to do much of this, and that will be also the case in the future. So using passive house technology, we can improve the amount of energy efficiency we add to what we have already done in the past. That was quite a lot, but we can do even more so that the overall primary energy demand will be not increasing, but can be decreasing in the near future. This is the additional efficiency we need when we add the renewable energy, which can grow at least as fast as the conventional energy production has been growing in the past decades, so that at the end we can, in a range of 2, 3, 4 decades, reduce all the fossil energy we need for the energy services we need in our houses, for our traffic, for all the other purposes, which are, of course, also important. So this is where I also have to come to look for the other advantages which a passive house will deliver for us. And first of all, of course, if I'm sitting in my building, I want to have it healthy. So we want healthy living. And the passive house can deliver for that. So if you look at the buildings which are not healthy, like these ones, most of the causes for this are moisture problems. We don't want to have that in passive houses, and we won't. Now, how does the passive house standard avoid this? Well, it has a improved insulation. It has reduced thermal bridging. It is really airtight, so that there is no condensation in the gaps. And we have a sufficient ventilation. Ventilation, of course, is very important with respect to the indoor air quality. This is something you can see here. It's a slide which is from a presentation of one of the former Passive House conferences. That was a conference where the German specialist on radon has been talking about the possibility of reducing the amount of radon contamination, of radon activity in our buildings. And what you see is that with the passive house ventilation, the radon activity in the building is as low as it is outside of the house. And you can't really do much better than this. This is also the case, of course, for all the other contaminants which we have in the buildings. In the past half a year, we have all been confronted with the COVID-19 pandemic. And we now know that COVID-19 is also spread with aerosols. The aerosols, these are small particles which are in the air and which can be in the air for quite a long time. It takes about 3 hours to breathe just half of what we have had in before. So it's quite important to have fresh air all the time. And that is exactly what the passive house can deliver. And this is what we can see in schools, for example. Well, of course, we have to make sure that everybody is also wearing a mask because the big droplets, those ones which might fly just a few meters and might hit your face or hit the surfaces, they of course can't be ventilated out. You have to be protected for them by a mask. But if you are wearing a mask, the aerosol can be avoided by the passive house ventilation, and this is what you see on that slide. So we will reduce the overall chance for getting infected by more than a factor 3, and that means that at the end the infection will die out because the reproduction rate will be smaller than 1. So it's not just the healthy building, it's also the comfortable building what the passive house will definitely be delivering. And this is what you see on the next slide. It's best possible comfort we can have. And this is the cold drafts which could come down from the window. And in normal buildings, the velocities can be up to half a meter per second, and it could be quite cold air what is coming down there. In a passive house, we have that very well insulating windows so that the surface temperatures are always above 17.5, 18 degrees. And this is what you also can see on this slide, where we can see a visible picture on the left-hand side and a thermographic view on the right-hand side. And you see that with a single pane or a double pane window, we still have cold window surfaces on the inside. But with the passive house window, the triple pane, double OE window, the surface temperatures are up to 17.5, 18 degrees. So that at the end, there is no differences in the radiation temperatures, and there is no cold surfaces, and there is no downdraft at all. And this is also the case, of course, in the dwellings themselves. The surface temperatures of the external walls, they are even higher than that. We have also structural protection by the air tightness, by being free of thermal bridges, by having relative humidities which can be guaranteed to be below 60%, by avoiding the temperature stress in the construction. And we have the corroboration of that by the long-term field test, which has just been published after looking into the data from the 25 years of the passive house Darmstadt-Kranichstein, where we have done some scientific research on how this building behaves right now. And the next quite important point is that passive house can be affordable housing. So in order to be a solution to mitigate climate change, it has to be affordable because it's much too expensive. Nobody will be able to do that in these 25 to 35 years we have for tackling climate change. So now the passive house will pay back by the savings, by the energy savings, even with a very low energy cost of the fossil energy. And we have already built examples which show that this is not just theory, this is really working. On the left-hand side, the self-heat homes in Philadelphia, an example of affordable construction in the United States of America. On the right-hand side, an example from Austria, where we have a €5 rent building which has been built in near to Innsbruck in Austria. So, and we have feedback from a lot of parts. This is from Australia, that the overall costs for living in a passive house at the end, including all the advantages we have been talking about, will be lower than the costs in ordinary buildings. And we will see this also in some of the presentations given at this conference. This is important because if the heating costs are lower than €300 or dollar per year, it means that the energy costs for the passive house component investment are in a range between 0 and 6 cents per kilowatt hour. So this is much cheaper than any kind of final energy you can have from whatever source you want. So that is even less expensive than the cheap fossil fuel energy. So that means that the passive house pays itself just by the saved energy costs, and you get all the other advantages we have been talking about. What is even more important, there is a value created by building passive houses or by doing EnerFit retrofits, and this value is mainly created with local enterprises. And this is the next thing I'm going to speak about. So this is a contribution to sustainability, and it's mitigating climate change. We have that problem of extinction of natural species. We have the danger of global wars, especially if we will have this problem with the fossil fuel. And we have water pollution. We have a shortage of certain rare earth elements. And in the contribution to the proceedings, I will come back to these topics even with respect to some of our examples in the conference. The passive houses have also a quite high resilience with respect to the climate change, which will already occur in the near future. What you see here is the final energy demand of several months in a passive house. You see red the heating, green is the domestic electricity, blue is the domestic hot water, and there is this blue part for cooling, like we have it nowadays in not very hot climates. But now if the climate is changing, there will be an increase, of course, of the cooling energy. This is what you see here. There's on the other side a reduction in the heating energy, so that the overall primary energy demand will be even a little bit less than it was before. So the passive house can also work in a warming climate. And if you look in the contribution of solar energy, this is the green part, you see that all that extra cooling energy is well within what can be delivered by the photovoltaic system, which can be mounted at the passive house itself. So it will still be sustainable even in a changed climate. We will have to look into the topic of embodied energy and embodied carbon. The Passive House Institute has a research going on this topic. It will be published at the end of this year and also next year, where we will give a method how to look into this topic with a scientific rigor. And we will see that there is indeed an additional contribution by using materials, by using natural grown materials, especially if you use natural grown materials for the insulation. It will even add another contribution to the reduction of climate gases if we do it in a consequent manner. And that's also already available on the market right now. So if we change from the conventional building materials to the natural grown materials like the straw or cellulose for insulation, like wooden panels for construction, we can even have some of the carbon captured in the structure of a building, and that will add to the energy savings and add to the carbon savings we achieve by the highly energy efficient construction. This is also being done already. We have already examples of these types of developments, wooden windows, wooden construction, straw insulation in the buildings. We have now more than 1,000 passive house components available on the market worldwide. They are being produced everywhere on the planet. There is no continent where there is not a production of passive house components. This is what can be done with passive house components. They can be produced everywhere on the planet. So we have these example of local production, which is also a quite important step for sustainability in the future. This will be local employment. The materials we need are available everywhere. The labor is available everywhere. It's not that difficult. You can learn how to do this. So this is being done everywhere. So we have production in Germany, we have production in Wales, we have production in the United States of America. There is production in Letland, there is production in Finland with straw bale construction you see here. There is production in Japan and in China, of course. And there's also installation in China. This is quite important because in China we have a lot of new construction going on. It's important that that construction at the end will be energy efficient, and there has been a big progress made since our last Passive House conference, which has been taking place in China, in order to have the knowledge also delivered to the Chinese partners who can build passive houses and can do passive house retrofits in China. Passive house and enerfit construction, that's of course always local. It's always a business which will create local employment. So the passive house is a concept which is forward-looking, which gives us an example of globalization in a sustainable sense. So it's not a material product, but it's the knowledge and it's the know-how that is being made available everywhere, so that the production can be localized. And that also gives us the possibility for participation in this development of science and of an open international society. Even if we look on the social sustainability, it's an interesting thing to look at passive houses because, yes, we have also a distribution of different consumption patterns where people will not perform differently from what they do now. It's very difficult to change the people's behavior. So you always have people who consume more than the others, and sometimes it's 2 times or 3 times more. So if you have a very high consumption, that would create a problem. But if you have a very low consumption, also this double or triple consumption is not very high, so we can tolerate that. So it's also a contribution to social peace, because the passive house consumption is so low that even the higher consumption don't matter. They won't change the average much, and the average is the only thing which is important for the sustainability, which is important whether we can deliver on the renewable energy side, and we can using the passive house principle. So it's nice to see that almost anything goes. These are examples of built passive houses and enerfit refurbishments in the past years. And you see It's everywhere on the planet. It's all climates. It's all architectural styles. It's all types of materials which can be used. It can be fully glassed buildings. It can be old buildings in a traditional way. It can be really modern architecture. Everything works as long as the details are done in a way as I have presented and as we will see in this conference. So from traditional to modern, from residential to schools, offices, even supermarkets, any use is possible. From concrete and steel to timber, all materials can be used. From Antarctica to Dubai, it can be built at any climate, and it can also build in any culture because it is not conflicting with the traditions of the different cultures. So Passive House, you've seen, it's so much more than a contribution to climate protection. And I hope that this conference will help to deliver on this topic. And I wish you a good information coming from this conference. Thank you so much for your attention.